But this artifact might not mean anything to you because we don't even know what a byte is. So to really go further, we really need to define bits and bytes. Now, a bit is a binary 0 or 1, and a byte is 8 bits chained together. And this is an important concept because we can store characters in bytes. And what I mean by that is that if we look at something like the character for a $sign, we could decide to store that in a byte given by a 0, 0, 1, 0, 0, 1, 0, 0. And we know that n number of bits have 2 to the n combinations or values, so 1 byte has 256 values. Now we include 0, so our range is from 0 to 255. That gets us our 256 values. But maybe you ask, how do we represent negative numbers in binary? And for that, we have to look at signed and unsigned numbers. Now this is all going to stem from something called the 2's complement. And how we use the 2's complement is we take a binary number, we complement each bit, and we add 1 to that complemented number that we get, and then we take the sum. And this should map us to our negative number. So if we look at an example, right here we have 6 in decimal. We're going to represent that in terms of binary. So this is step 1. Step 2 is to complement each bit. So we flip each bit. And then step 3 is to add 1 and take that sum. And if we do that, we get a number here. And ideally, these numbers are not going to match. And the output of this number is going to represent -6 in decimal. And that's what we were trying to get when we used the 2's complement on +6. So to go backwards, we can do the same procedure. So right here we have -6. We know the representation of that now in binary. So that's step 1. Step 2, we complement each bit. Then we add 1 to that. And if we do that, we can look at the result and notice that it is the exact same as this result here. So that maps us back to +6. So what we really need to know is if the binary set of bits is signed or unsigned. Because if it's signed, we can actually get some negative numbers out of that. Now maybe something more important is what is the range of a signed byte? So we know that we're going to have 2 to the 8 values, which is going to be 256. If we are unsigned, we have a range of 0 to 255. But if we're signed, well, do we have -255 to 0 or something else? So let's look at a few conditions. And first we're going to take 0, because that's always easy to work with. So the decimal representation is here. We take the complement, which is all 1s, and then we add 1. Notice that we have this continuous rollover here. And this is our number. Notice here there's 9 bits. And if our system is only working with 8 of those bits, this 1 is ignored. And we're only really considering these 8 bits here. Now notice that these 8 bits are the same as these 8 bits. So did something fail? And the answer to that is no. And the reasoning is pretty simple. 0 maps to -0. We would not expect 0 to map to anything else besides 0. So let's look at 128 decimal. So we know that that's going to map to this in binary. We take the complement, add 1, and what we get is this result here. Notice we only have 8 bits, but there's something interesting. Again, we have the terms matching, so something's not right there. And let's just keep this in mind, because if we look at 127 in decimal, maps to this in binary, take the complement, add 1, well, we get something here. Again, 8 bits, and these do not match. So what we could say is that this maps to -127 in decimal. So we took 1 away from 128, and it seemed to be okay. Let's add 1 to 128 and see what happens. So we're going to look at 129 decimal. That maps to here. Take the complement, add 1, and this is the term we get. Notice it is different, so that's pretty cool. We have 8 bits, so that's pretty cool. And everything seems okay until we look back at what we just did. Notice this value right here maps exactly to this value So if I gave you this value right here, would you say that it is equal to minus 129, or is it equal to 127? So now our smiley face is destroyed by anxiety. And if we look at our examples, really what we had was 0 maps pretty fine, 128 gets a little bit weird, 127 seems okay, and 129 just creates headaches. And we know that the 2's complement of 0 sends us right back to 0, 128 maps us to 128, and 129 maps us also to 127. So it might be helpful to actually represent these as binary. And we might need to fill in one more value here. So let's scroll up just so we have a little bit of room, and let's look at the case of the 2's complement of 1. So that maps us to all 1s. So we can fill that in on the number line. And now we can look at what's actually going on in the number line. So if we look at 0, you can see that that's all zeros. If we go up to 1, we increase by 1. If we go down to minus 1, kind of flip everything. And notice for 127, we kind of just have 1, 0, 0, 0, and then 0, 0, 0, 1. So it looks like from going even more negative, we decrease this value. And then notice when we looked at 128, we kind of started breaking things. And if we kept going higher, we broke things even more. So what's fundamentally different about 128 and 129 as compared to 127 and 1? And it might not be so obvious, but let's look at the first bit here on the left. Notice for 128 and 129, that's a 1. For 127, that's a 0. For 1, that's a 0. Okay, so something's going wrong when this most left bit is a 1. So what do we really see here? Well, we see that if we have negative numbers, that leftmost bit is a 1. And if we have positive, it's a 0. But we notice here, if we keep decreasing and decreasing, we still have one more value that we can have here. And that's going to map to 128, or minus 128. So that's going to map to 1, 0, 0, 0, and 0, 0, 0, 0. And this may seem a little bit weird because you might think that minus 128 should have a lot more 1s, but it doesn't. And what actually turns out is for the 2's complement, the leading bit, or what we call the most significant bit, often abbreviated as MSB, that's going to indicate whether we have a positive or a negative number if it's signed. So if it's a 0, we have a positive number. If it's a 1, we have a negative number. So if we look at n bits, what we can say is that the signed range is minus 2 to the n minus 1, and that's going to go to 2 to the n minus 1 minus 1. So in the case of a signed byte, we are minus 128, 127. That is our possible values. Now this is another long video. Maybe it'll be broken up into 2 parts. If it is, thank you for watching. Hope you learned something new. Like, comment, share, subscribe. Helps the YouTube algorithm, and we'll see you in the next video.